Last week, SpaceX and Tesla CEO Elon Musk announced bold plans to combine the technologies of his two biggest companies by placing rocket thrusters on future specialized models of Tesla's Roadster. The thrusters won't actually combust, according to Musk. Instead, they will expel highly pressurized cold air, giving the Tesla an extra boost in acceleration. It's a move that might technically work, but it also baffles industry experts and engineers. The thrusters won't be very efficient and probably won't be street legal. Specifically, Musk is talking about incorporating a key piece of hardware from SpaceX's Falcon 9 rocket, a tank known as a composite overwrapped pressure vessel, or a COPV. These bottles are made out of a thin metal liner that's wrapped in carbon fibers, and they're a great way to store a lot of pressurized air in a very small space. They're also fairly lightweight, which is why many rocket manufacturers like using them to help pressurize their rockets. On the Falcon 9, the COPVs sit inside the propellant tanks and keep them pressurized during flight. As the rocket climbs to space, the propellants rapidly empty from the tanks, and it's the job of the COPVs to replace those liquids with helium so that the tanks maintain their shape. The compressed air inside these bottles isn't being used to propel the rocket directly. Some automobiles use COPVs too. Buses and trucks use them for storing compressed natural gas, and cars with hydrogen fuel cells also rely on COPVs. But the air inside these tanks is used as fuel for the motors inside these cars. With the Roadster, Musk has a different idea. He wants to use them as thrusters, where they blow air out of the back end or front of the car to help propel and stop the vehicle. It could potentially blow out the sides, too, to help with turning at high speeds or in tight corners. Commercial cars have never used COPVs this way before, and the idea raises a lot of questions about safety and efficiency. For one, the Tesla Roadster already accelerates and brakes incredibly quickly, and the new Roadster is supposedly one of the fastest cars in the world, with a 0-60 time of 1.9 seconds. It's so fast that there's vigorous debate about whether any modern tires can ever go faster. So the COPVs would need to blow out a lot of cold air at super high speeds to push even faster acceleration or deceleration times. That will require a lot of power and some fairly large tanks to have any kind of discernible effect against some real limits of physics. And if truly affecting speed is the goal, these thrusters would be extremely loud, prone to extreme temperature changes, and possibly put other cars on the road at risk. Is it an option? Yes, Sam Abu-El-Samid, a senior research analyst at Navigant, an advisory firm for the auto industry, tells The Verge. Is it a wise option? Absolutely not. It's the most ridiculous thing I've ever heard of. Close quote. Many car manufacturers have looked at ways to use compressed air to power vehicles, though. For example, in 2013, French car manufacturers Peugeot and Citroën announced plans to build a hybrid vehicle that used pressurized air as a source of energy, though the development has been put on hold. These designs typically work by releasing air from a container in a controlled manner to drive an engine's turbines or pistons. Compressed air cars are hailed as environmentally friendly, since they don't burn gasoline. But the downside is they're not super efficient. For 1, compressing air takes a lot of energy. Musk claims that the air will be replenished in the COPVs using an electric pump, which would draw from the Tesla's power pack. But experts argue that could significantly drain the battery voltage needed to drive the car. It would surely eat away at the energy stored in the battery. Dave Sullivan, a manager and product analyst at Auto Pacific, an automotive consulting firm, tells The Verge. The range calculation, or the test cycle for the range of an electric vehicle, does not take into account this idea. Of course, it all depends on how effective Musk wants its COPVs to be. Cold gas thrusters have a relatively low specific impulse, which means they need a lot more fuel, or air, in this case, to get a decent amount of thrust. This makes them good for satellites in space, which don't require a whole lot of thrust to maneuver in a vacuum. But on the road, with air resistance and tire friction, cold gas isn't as powerful. So the Tesla COPVs will have to be large and bulky to store enough air needed to have any kind of major effect. It seems like to have a thrust that's going to have a meaningful amount of energy, it's going to take a pretty decent amount of size and capacity in the tank to be of any real performance benefit, says Abu El-Samid. Musk did say that COPVs would take up a good chunk of the car, turning the 4-seater into a 2-seater. Right The company could potentially fill the COPVs to a higher pressure to save on space, but the tanks would need to be much stronger and heavier to be considered safe for passengers. The more pressure you want in a commercial car, the sturdier your tanks need to be. The COPVs that Musk wants to use are upgraded ones certified for the Falcon 9 rockets that will carry crews to the International Space Station. This is by far the most advanced pressure vessel developed by humanity, he said at a press conference before a SpaceX launch in May. It's nuts. Still, the idea does bring many safety issues to mind. While crucial for spaceflight, these COPVs have also been a source of anxiety for SpaceX. In September 2016, a COPV caused a Falcon 9 rocket to explode on a Florida launch pad while the vehicle was being fueled for a test. SpaceX claimed that friction between the propellants in the engine tank and the COPV was to blame. The super-cold liquid oxygen that SpaceX uses for its Falcon 9 reacted badly with the carbon fiber that was wrapped around the COPV. SpaceX has significantly upgraded its COPVs since then, and any bottles put into a Tesla won't be surrounded by cryogenic oxygen. Still, when air is released quickly from a highly pressurized bottle, it does experience extreme temperature changes. The faster that air is released, the colder the COPV will become. So if the Tesla is going to blow down these bottles quickly, they could easily reach super frigid temperatures, which would make the COPVs brittle and less structurally stable. Tesla could combat this by blowing the bottles down more slowly, but then the thrusters won't have as big of an impact on the car. and depending on how fast the air is blasting, the thrusters could pose risks to other cars on the road. If the COPVs are going to have any significant force on the Tesla, they'll also have a significant force on the cars surrounding the Tesla. Cold gas thrusters can get to a specific impulse of about 70 seconds. That means the gas leaving the COPV could reach a little more than 1,500 miles per hour. So the air has the potential of sending fast-moving debris at a nearby car, or even pushing on surrounding vehicles. But even if Tesla figures out workarounds for all of this stuff, there's the noise to consider. Releasing lots of highly compressed air is loud. There are regulations in place about the amount of pass-by noise a car can have, and it's doubtful the thruster-outfitted Tesla will meet those. Gasoline vehicles can't make too much noise, says Sullivan. I can only imagine this would be extremely loud and not be street legal. Close quote. Musk did say the car is not recommended for urban environments. So adding COPVs to a Tesla is doable, though they probably won't be allowed on any major roads given the risks. Still, it's a whole lot of complicated machinery to make an already very fast car go slightly faster